Hello all, and welcome to our breakout session on intelligently leveraging the A in CAD. My name is Wouter Nees, and I'm leading the AI team at Bricsys. In this session, I want to talk about Bricsys' vision of the A in CAD. At the end of this breakout, I hope that you'll all understand what the A in CAD actually means for us and how we are putting this in practice in our BricsCAD products. So, what is the point of A in CAD? Despite the meaning of the abbreviation CAD, historically, CAD software hasn't done a great job in really aiding the user. So, you could ask yourself the question, what does it really mean to aid the user? Is it about replacing his pen and paper by basically doing very similar operations, but now with a computer? For sure, we believe not. This is the status quo we need to challenge. Is it then about AI, about generative design, about fully automating the creative design process by a computer? At Bricsys, we also don't believe that this is the way forward. For us at Bricsys, making the computer aid users in their design is all about accelerating your design workflows. And we take this extremely seriously. So, the typical day of a designer working with CAD software consists of two types of tasks. On the one hand, they do high-value, creative design activities, solving problems, developing solutions for their customers, and so on. This is the fun stuff. But also, there's a lot of repetitive, laborious tasks that inevitably have to be done alongside the more interesting tasks. With BricsCAD, the aided in CAD means helping designers get as much of the low-value work done as quickly as possible by automating most of the repetitive tasks. This then gives the users time for more of the high-value creative tasks and doing actual design work, which results in better, more innovative outcomes and faster delivery of the design work downstream. This could mean getting better products to clients quicker or just earlier fulfillment of contracts, essentially enabling the organization to get paid faster. You might think this is all very nice marketing talk, but I'm here today to prove it's much more than only marketing talk. In fact, it's my day-to-day job at Bricsys to bring this vision in practice, leading a team of highly talented and motivated R&D engineers to build the tools of tomorrow that do exactly this, automating the repetitive tasks, accelerating your design workflows. And to prove my point, I'm going to showcase how BricsCAD intelligently leverages the A in CAD based on 3 real design workflows. First of all, checking drawing health and finding outliers. Secondly, quick 2D and 3D editing. And thirdly, structuring, organizing, and reusing drawing content. So let's go. As you might already know, we are extremely focused on creating tools that maximally improve the quality of your design data. So let me prove my point. Tools like Audit, Purge, and Overkill have been out there for quite a while, but they are still there to help you and support you when it comes to fixing DWG database errors, removing unused objects, and duplicate geometry. With the release of BricsCAD v21, we have introduced a suite of drawing optimization tools, containing already existing commands like Audit, Purge, and Overkill, but also adding new tools that leverage the power of AI. BricsCAD Lite v21 was the first release of the Optimize command that detects and fixes small geometric inaccuracies in 2D curves, such as rectifying lines and closing small gaps. In parallel, the Simplify command also saw the light in v21, aiming to remove unnecessary detail from polylines, splines, and hatch boundaries. With BricsCAD v22, we've continued this path and made a lot of functional extensions and improvements to the tools in the drawing optimizations suite. The Optimize tool now got a 3D mode, optimizing the faces of 3D solids. And the overkill command also got a new mode to delete duplicate block definitions in the database, which is reusing Blockify technology. And today, with the release of BricsCAD v23, we have further extended the possibilities with a new Find Outliers command that smartly detects objects that are out of the regular drawing area. And, more importantly, we have grouped most existing and new drawing optimization tools in a single, powerful command, Drawing Health, with a clear UI helping you to apply the relevant health checks for your needs. So let's have a look at these tools that will help you checking drawing health and finding outliers. In the Manage tab of the Drafting ribbon, you can find this drawing optimization tab, which contains all sorts of drawing optimization tools. For example, you can manually launch the purge command, which pops up this new nice dialog. Or we can launch the overkill command and choose the duplicate block definitions option, where we can specify the entity properties to ignore. However, we need to know what we want to do. With BricsCAD v23, we have released this new drawing help tool, which combines all existing drawing optimization tools in one convenient location. With the routine editor, we can quickly see the tasks which we want to be performed. We want to do the purge check, which is actually looking for reduced objects. We want to audit the database. We want to look for duplicate block definitions. And we want to check for geometry which matches existing block definitions. So let's go. Here in the command panel, we can see the exact same visualization as in the purge dialog. So there are 19 blocks which are not used, 60 layers which can be purged, 10 materials, 2 dimension styles, and 3 text styles. Further, you can see that Audit has analyzed the database and has found some issues. With one click, we can fix them all. Happily, it seems that there are no duplicate block definitions in this DWG file. Finally, the last task has found some geometry in the database which is corresponding to geometry inside existing block definitions. For example, you can find these 5 instances of a double bed, or these 18 matches for a door. You can see that the combination of the command panel on the right and the widgets on the left offer extreme control of which objects to convert to blocks and which not. In the end, we get presented by a nice report listing what has been done. We can see all the purged objects, we can see the result of audit, and also the result of match existing block definitions. But there's more. Let's also look for outliers with the new Find Outliers command. This command will draw an OK area on the screen in green. This one we can tweak with the parameters here on the screen. For example, we can change X size to 4000. If we're happy with the size of the OK region, we can now inspect for 5 outliers, and actually we can see a list of objects which are not in this green region. We can use the zoom button to find them, and indeed, it seems that they're quite far away from the rest of the drawing. Using these widgets, we can click to zoom. And let's just delete them. As such, you can see it's really convenient to detect and remove outliers in your drawing. So, as a second design workflow, I'd like to focus on some smart detailing and modeling tools we have released over the past years, speeding up 2D and 3D editing workflows. With BricsCAD v20, we've added a smart alternative to one of the most used commands, CopyGuided. Unlike the regular copy commands, CopyGuided takes the 2D context of the entities to be copied into account, resulting in smart magnetic snapping behavior. And after releasing CopyGuided, many users started asking for the logical next step, a smart, context-sensitive variant of the move command, which is by far the most used command in any CAD system. So next to magnetic snapping to candidate target locations, MoveGuided also nicely cleans up the context of the initial location. For example, healing lines, edges, and so on. And with BricsCAD v22, a 3D variant of the CopyGuided technology was born. And we made a fuzzy version of inserting parametric blocks in a guided way. Now, 2D blocks parametrically adjust to the candidate's target location. As such, a 2D block representing a door can now easily be inserted in a wall with a slightly different thickness. BricsCAD V22 also brought the first version of the arrange commands, enabling users to quickly align or distribute multiple objects in 2D or 3D. And today, with BricsCAD V23, we add a nice-looking command panel to the arrange commands, increasing your productivity even more. Finally, we've also added the connect command, which connects multiple curves in a 2D plan, even if they're not touching. So let's have a look at the tools that will help you to speed up your 2D and 3D editing workflows. First, let's have a look here at the room at the top left. We can see that some of the chairs are missing. I'm sure you all know the CopyGuided command, which you will use to quickly select one of these chairs and its surroundings. We will use the blue arrow indication to dynamically snap to the arc of the table. As such, we can very quickly add 2 chairs. Similarly, we can use MoveGuided to move objects in the same guided way. So let's launch it. For example, maybe we want to move these cabinets here from one side of the room to the other. Let's select it, and again, these 2 blue arrows indicate how the cabinet will snap. It's just that. Or hey, maybe here the sink in the kitchen area. We want it to be more centrally placed in the kitchen. Again, by selecting them and snapping to the desired location, we can even use the dynamic dimensions. We can easily place this sink in the place we want. Also, CopyGuided works in 3D. Let's have a look at the 3D model behind this plan. For example, you might want to copy this detail from one of the floors to the others. Let's again launch the CopyGuided tool, but now switch to the 3D mode. We can quickly select this object as a detail solid, and then we can see automatically the reference faces are selected. Like this, we can quickly, with a few clicks, add the detail corner to the other floors. Just like that. Moving back to the plan, we can see that for some reason, some of the chairs in the bottom left room of the plan have been scattered around the room. There's even one chair on top of the table. Let's use the new Tool Palettes panel from where we can launch the arrange command. We select the 3 chairs and get presented by this nice command panel. In the Y direction, we do want to align the chairs along the bottom direction. We can click on the temporary graphics and snap to the chair in the other room to make sure they are positioned in the way we want. Further, in the X direction, we want to distribute the chairs equally by gaps. Again, we can use the red temporary graphics to slightly move the ends to the position we want. This tool also works in 3D. For example, in the 3D model, you can see that these columns on the separate floors are actually scattered all over the place. We'll again use arrange, select the columns, and center them on both the Y and the X direction. Again, we can see this temporary graphics, where we can even use them to click and reposition them on the place we want. And finally, in the 2D plan, we can see that for some reason, there are some gaps. For example, here, this kitchenette, these 4 lines are not connected. Let's just quickly use the new connect command. Just like that, the 4 lines are connected and even joined into one single polyline. This tool is really as simple as it sounds. Select the entities, run the connect command, and the objects get connected. For some lines, but it also works for arcs. For example, here, in this nice triple bed, you can select the arc and the line and connect them just like this. As a final design workflow, we at Bricsys are eager to deliver features and functions that bring order to the chaos. We have our users to organize drawing content in a more structured, logical, and compact way than any other CAD system. We started this journey back in 2018 with the release of BricsCAD V19. There, the first Blockify tool has been released, at that point only supporting 3D solids, to automatically and quickly find equal solids in model space, and to replace them with block refs. At the same time, the parameterize command was released, fully automatically creating the relevant 3D parameters and constraints for your 3D designs. 1 year later, with BricsCAD V20, we extended both the Blockify and the parameterize concepts to 2D. And here, users could specify a selection set of 2D entities. Blockify will automatically start looking in the search space to find the repetition of this 2D input set. And the auto-constraint command, which is similar to parameterize in 3D, would automatically create 2D parameters and constraints to enforce the relationships between the 2D objects. In BricsCAD V21, we released groundbreaking AI technology in the parametric Blockify commands. Not only you could now find and replace fully identical objects in model space, but also geometric variants of an input parametric block or a parameterized 3D design would now be identified by parametric Blockify. This tool then replaces these geometric variants by parametric blocks, with the correct parameter values, of course. In BricsCAD V22, we've taken the Blockify concept to the next level, not only automatically finding all sets of equal single 3D solids, but now also automatically building maximal collections of 3D solids. Of course, there are often multiple possibilities, so we decided to present the connection alternatives to the user, which was the first use case of the command panel. And finally, today, with BricsCAD V23, we again take a huge leap forward in assisting our users to organize their drawing content in the best way possible. We've added a new array detect command that detects patterns of 2D or 3D objects in a search set and replaces them by array entities. And we've also extended the range of applicability of the parametric Blockify command to now also support 2D parametric blocks with 2D parameters and constraints and flip lines. As a final demo for this breakout session, let's have a look at the tools that enable users to represent their drawing data in the most logical, structured, and compact form. Here again, we'll start from the Manage tab in the ribbon. Let's launch Blockify. We see that directly a nice command panel pops up, listing all the settings and options. This first time, we'll choose for the Match Existing Blocks. This option analyzes the model space, looking for plane geometry that matches with existing blocks. In this case, we can see that 5 times groups of 2D plane geometry have been found matching the geometry of this double bed. Using the widgets, you can decide which beds to convert and which ones not. After Blockify, you can indeed see that this bed has now become a block reference, while this bed is still a bunch of lines, polylines, and arcs. As a next step, we will zoom in to the right bottom of the plan, where we can see there is an arrangement of chairs and a table. By selecting all these entities, we can see it consists of almost 1,500 arcs and lines. You can imagine that this is not the most ideal form to represent design data. So let's again launch the Blockify tool. This time, we'll select all the entities representing one chair. By doing this, we first get prompted to specify the block name. We'll choose chair. And now we can see that everywhere in the plan, all the chairs are represented with a green check mark, which is indeed what we want, because we want to replace all the geometry by blocks to this chair. We can do the same thing to this table. So we again run Blockify and use simple block select. to get all the entities belonging to this table. We'll name this block table. And again, we can choose which ones to convert and which not. We can go one step further, grouping together all the chairs and the table for this one arrangement. So one last time, we launch Blockify, select all the chairs and the table, name this object to table and chairs, and accept all the suggestions. Just like that, if we now move to the structure browser, we can see that this file contains quite some block references, but indeed, some of them are individual chairs, while other are this combination of tables and chairs, which actually again consists of individual blocks. Next, we can see that this cooking device in the kitchen areas actually consist each time of 4 individual circles. Again, this is not ideal. So let's launch our new array detect command. First, we specify the search space to be exactly the entire drawing. And now we can choose whether we want to select source entities or we want to automatically detect all the arrays consisting of a single entity. For performance reasons, we choose the first option and it will go for one of these circles. Again, command panel pops up showing that 5 patterns are found, each time a combination of 4 of these circles. By converting them, we can indeed see that the result is now 5 times array instead of 5 times 4 individual circles. I can see over here that one of these blocks is a parametric block. We can use the properties panel and use the flip parameters. For example, flip the swing side of the door, or we can also flip the sides of the wall. Now we will launch the parametric blockify command. And just like that, in less than a second, we can see that all these doors now have been converted to parametric blocks indicated by the green flip lines. This is actually quite nice, because now we can decide for every door whether or not we want to flip the door. For example, this one, we can flip to the other side of the wall. This concludes the demo. So, I've taken you over 3 realistic design workflows. And hopefully, the timelines of features and functions and in-product demos have convinced you that we take the A in CAD very seriously. So we've talked about checking drawing health and finding outliers, about quick 2D and 3D editing, and about structuring, organizing, and reusing drawing content. By defining the A in CAD as accelerating your design workflows, we are convinced to have found the sweet spot. We don't only do this in BricsCAD Lite and Pro, but we're also working actively on accelerating design workflows in our vertical solutions, BricsCAD Mechanical and BricsCAD BIM. As such, tools like BIMify and BIM Automatch have already proven their value by adding BIM metadata, such as classifications and compositions, fully automatically. And further, we're also adding automated generation of construction documentation for a 3D BIM model with tools like type plans and BIM dimension. And in a mechanical context, we are looking into design for assembly. How can we automatically check assemblability in the design phase to avoid unpleasant surprises during assembly? So, with all of these accelerated design workflows in BricsCAD Lite, Pro, BIM, and Mechanical, I hope to have convinced you that for us, A in CAD is really about accelerating your design workflows. But how can we take this to the next level? What's the next step? How can we leverage the A in CAD even more to deliver unrivaled accuracy? We believe that some generic tools and functions will, in the end, reach their limits. To further improve the accuracy of our smart tools in the context of your design workflows, we believe they need personalization through machine learning. So if you be interested in this next generation of our smart tools with even higher accuracy due to personalization, don't hesitate and join our BricsCAD usage data program. Not only will you co-decide in the future the product development of BricsCAD, but you'll also directly benefit from improved and personalized features, such as AI Assist Ribbon tab. So this brings me to the end of my presentation. By intelligently leveraging the A in CAD, BricsCAD lifts creativity and reduces complexity. Thanks for watching.